unpacking this question, what we realize is that it's an approximation. Um, so what does that mean? Well, it means that we're going to have to figure out some method that we can estimate y. And we do have a couple of options. One option that I used when I did a similar question to this was to realize that y is probably around 2. That's because 2 to the power of 4 is 16. So this is some sort of key fact that I had in the back of my head when I was asked, or I wasn't asked this exact question, but something similar that I used this sort of logic. What I then did was broke 16.01 into 16 plus 0.01 and then managed to factorize out that 16. So it looks something like this. And I think it should be a bit more obvious what we can do here is that we can try and, well, first let's simplify this fraction over here, which we'll get 1600. And yes, right now we should be able to see that we can do a binomial expansion where the exponent would be a quarter. So if we take the fourth root, and we'll just stick to the positive solutions here, what's positive solution, we would have 2 outside the bracket because 2 to the power of 4 is 16 as we just mentioned above, and the same thing inside the bracket for now to the power of a quarter. All we have to do from here is expand this using binomial expansion, and this is where our approximation comes in. So where do we cut off the binomial expansion? Do we cut it off the first term? Or do we go for a bit more? Well, we should see that it's actually obvious where we're going to cut this term off. But if we just start off, we have 2 outside, we have 1 plus a quarter times 1 over 1600. And I'm just going to write down order of 1 over 1600 all squared. And then this ends up, I should put another bracket around it. This ends up becoming 1 plus 1 over 6,400. And then we just multiply the 2 to get this. And then 6,400 over 3,200 plus 1 over 3,200. We get 6,401 over 3,200. And this would be our approximation. Now, why did I ignore the square term here? And you can sort of see that this is on the order of 1,000. And we're squaring it. So, order of 1,000 squared rather, 1 over 1,000 squared. So this ends up being 1 million, on the order of a million, around that value. So if we're going to divide by a million, and the current answer we have here is dividing by 1,000, we are well within the range where any number that we're going to get from this value is not going to influence the decimal place that we will get using this approximation here. So we're good. We're good with this approximation right here. If we were to try and actually calculate using a calculator, we'd get this value for this fraction. And the actual value for the cube root of 2 up to a various number of significant figures is 31243. So 2.00031243, and that'll be the cube root 16.01. So you can see it's relatively accurate, our approximation. And yeah, we could probably say that up to about 3.1 is where it'd be accurate, and then obviously this is a 5 and this is 4, so the rounding error would be there. Another way we can look at it is if we were to use a similar sort of thinking, we'd go back to y to the power of 4 is 16.01. And how about we say that y is probably 2 and a bit, where we're going to say epsilon is what this bit is. So what we're going to do is we're going to use a binomial expansion. And if you're in year 12, you probably are going to be a bit more comfortable with this, because this just is the binomial expansion you learn in AS level. And if we just go around just calculating each terms of the binomial expansion using Pascal's triangle, so that'd be 1, 4, 6, 4, 1. So we start off with 16, that's 2 to the power of 4, plus 4 times 8, that'll be 2 cubed, times epsilon, plus 6 times 4 times epsilon squared, plus 4 times 2 times epsilon cubed, plus epsilon to the power of 4. And this should give you 16 plus 32 epsilon plus 24 epsilon squared plus 8 epsilon cubed plus epsilon to the power of 4. Now what we're going to say is this bit epsilon is we're going to just include only the linear terms. So that means this goes, and this goes. And we're just left with 16 plus 32 epsilon equals y to the power of 4. And what did y to the power of 4 equal? Well, it equals 16.01. And that equals 16 plus 32 epsilon. We take away the 16, 0.01 equals 32 epsilon. 1 over 100 equals 32 epsilon. And we divide it by the 32, and we're left with 3,200, 3,200, whatever you want to call it, equals epsilon. All we have to do is now go back to our original equation for y, is what we said, y equals 2 plus epsilon, and this would just be 1 over 3,200 plus 2, so we're just back to 6,401 over 3,200, and we get the same result. And yeah, that's all we did. This method probably is a bit more intuitive to those who aren't familiar with the binomial expansion of fractional powers, but yeah, this is it.